Welcome to the Analytics Engineering Podcast, featuring conversations with practitioners inventing the future of analytics engineering. Today, I'm speaking to Dr. Eirini Kalliamvakou, a senior researcher at GitHub Next. Eirini has built a career around studying software engineers, how to measure their productivity, how developer experience impacts productivity, and more. Recently, Eirini has been working on quantifying the impacts of GitHub Copilot. Does it actually help software engineers be more productive? Our conversation builds up to this point, starting with how you quantify developer productivity in the first place, and finally, arriving at whether or not Copilot actually makes a difference. It goes without saying that Copilot-type experiences are touted as one of the killer apps for generative AI. In the search for real business value, this research is a real bellwether of things to come. Without further ado, let's get into it. Eirini, welcome to the Analytics Engineering Podcast.
Thank you. Thank you for having me.
I will have introduced you at the very beginning of the episode, but why don't you take a minute to just say hi and talk a little bit about your background?
Well, hi to everyone, and thank you very much for having me here. I'm Dr. Eirini Kalliamvakou. I am a staff researcher at GitHub. I have a pretty exciting role there. I'm part of GitHub Next, which is GitHub's innovation team. So we get to do all the cool stuff. We explore the future of software development. So it's always exciting. We always try to look ahead. We develop prototypes of developer tools. We use research to evaluate them, which is where I come in most of the times. And then, depending on what we see, we maybe incubate new products for a while, or we repurpose them for future explorations and so on. So I run research that helps us understand what matters most to developers so that we always keep that in mind as we're exploring the future and we're looking forward, that we're always grounded in developers' needs and developers' motivation is really important.
That's what you do at GitHub, but you have an academic career as well, and I have to imagine. So I'm kind of on the edges of the software development community. Analytics is its own little world that shares some common traits, but I have to imagine that many software engineers don't like being poked and prodded and studied from the outside by somebody who is not of them. But I think your background, you actually have done software development in your life. Is that correct?
I have not done software development. I have done a lot of studying on software developers.
Okay.
Yeah. And that has not only is that a core part of the job that I'm doing now and why I have the role that I do, but I have found that developers have always been very open to being studied and talk to people, even if they're not within the software development domain. If people have an understanding of the work that developers do, and especially the complexity of the work that they do. I think there's always reluctance, and because some of the background, some of the research that I've done in the past has very much to do about developer productivity, and that's always a very touchy subject.
Yep, we'll get there.
Yeah, definitely. But that's one example of a point of, I think, disappointment and frustration when a lot of the time people try to study developer productivity. And what they do is really they bring their magnifying glass and they're like scrutinize what developers do and how much of it they do and how long it took them. And that's all we ever talk about. I have found developers to be very open in discussing their productivity, and they have a lot of interest in improving their own productivity if it's studied right and if it's looked at holistically and not just we only ever look at the one thing.
I'm fascinated to get into that. It's a weird thing to be obsessed with, though, right? Like, I'm just curious, if you were not a person sitting at a keyboard, like responding to pull requests or whatever, like in the workflow, how did you find yourself being interested and curious about this subject matter?
You know, I've asked myself that so many times. I started out in economics. That was my undergrad. And then gradually I found myself being more and more interested in tech and tech work, but mostly how it happens rather than doing it myself. And so like my master's, for example, was in decision sciences, where there was this, and e-commerce was really big at the time. And so there was this intersection between building systems that help like e-commerce, but also understanding the economics behind it and try to model, performance of systems, performance of data, performance of like all of these things. And that's just very natural. In the department that I was in and the professors that I had were very much into software engineering and empirical software engineering. So it just drew my attention to this field of software development where a lot of really complex work happens. There's a lot of research that attacks or like tries to understand and improve the technical parts of the work, and not nearly as much research that tries to look at more of what we call the social aspects of software development that end up affecting everything, the quality of the work, the productivity of the people who do the work, and so on. I found that fascinating. It was a very clear gap there. There's not enough talking about this and empirical studies and data to back up the discussions around developer productivity. And it was just fascinating, like too fascinating to resist. So I started going deeper and deeper and deeper. And then all my academic career after that, and then my transfer into industry and my job at GitHub, if I look back, they all feel like they were one straight line. Of course, it never is, but it feels like it has been a natural progression that way. Yeah.
Got it. That's fascinating. I want to dig into some of the work that you have done and published about with Copilot, with developer experience, how all of this results in more and less productive software engineers. It's a big topic. Maybe to start out with, you mentioned Next, GitHub Next. Can you frame like kind of the set of total things that your team there thinks about? How much of that is Copilot? Are there like big pillars in terms of like what you research?
So there are. We're trying to not tie ourselves to one particular technology, because if it's the future that we're thinking about, we have to look at it from a few different perspectives. Right now, AI seems to be a big part of what we expect the future to be about. So of course, there's a lot more attention in AI powered developer tools and developer experiences. And that to us means not Copilot the way it exists today. Copilot did originate from GitHub Next. It was one of the
Oh, that's so interesting.
early incubation.
So you're not just doing research, you're like doing experimental product development too.
It is research and development,
Okay.
for sure. That's why I said it's an innovation team. We have a lot of researchers, but it's always very applied research, and it's research that is eventually going to end up in the development of prototypes, which may or may not end up being products. A lot of them have, but other remain ideas.
Got it. But like for example, there are product innovations that GitHub has released that maybe don't feel quite as out there as Copilot, like GitHub Actions. Did that come out of Next?
No. I think that GitHub Actions is an example of, let's call it more of a incremental improvement. So we tend to think about like horizons. We're trying to not be sticklers about it, but
Sure.
let's imagine that there's like horizons 1, 2, and 3, and horizon 1 is kind of like the immediate needs and incremental improvements to experiences and tools that already exist. And then horizon 2 is more of like strategically, where do I want to go with this portfolio of products potentially? And then if we're thinking about horizon 3, which is where Next tends to operate, you're thinking 3 to 5 years out. I mean, with AI now, all of these timelines have shortened so much. But you're trying to think, what do I think developers are going to need? How do I think software development is going to end up happening? And how do I get ahead of that in terms of designing not just tools, but also interfaces, which has become more and more important. Again, with AI, we're realizing that it's not just add this functionality everywhere. You have to rethink main workflows, integration with other tools. All of these things need to be, and that's why we keep talking about AI native tools, which is you rethink the existing processes from the ground up with AI.
Yeah, we're like back at Xerox PARC where we've got to figure out the mouse and the keyboard and everything.
Yes, very much so. Yeah, it feels like that.
Okay, we've talked about, we've like mentioned Copilot multiple times in this conversation already, but can you give us a little bit of background on Copilot? I think Copilot came out ahead of ChatGPT, which is interesting because it means that clearly it predates the groundswell of attention that AI has gotten. So that's interesting. I don't know if GitHub Copilot was the first instance of the productization of the word Copilot. I'm just curious, how original is this thing, or were people doing stuff like this before?
So yes and no in a couple of ways. So fundamentally, Copilot is an AI powered code completion tool. So as developers are in their developer environment, in their editor, and they're typing, they're writing their code, they get suggestions from Copilot. Sometimes that means completing the line of code that they are writing. Sometimes it means that it gives them much longer snippets. Sometimes it means that they wrote a comment and then it suggests code. So the concept of auto completion was not new.
Sure.
Right. So that existed. And so from that perspective, yes, this was an existing idea. The AI powered completions and the way that Copilot suggests them. So that's where the interface comes in, right? It doesn't have a special interface per se, but the experience of it appears as gray italicized text, which we call ghost text, makes it very easy to just ignore it and keep typing if it's not something that you're interested in, or it's not a suggestion that fits exactly what you were going to write. But it also makes it very helpful when you do accept it, because it kind of like gives to you this boost of progress, right? You further down what you were going to write. That part was novel, and it was what was novel about it were like also the inner workings, right? The model that it was using that was trained on code. So it was very context aware and very specialized in giving really great code completion suggestions, more so than your typical auto completions. That was definitely part of the kind of the game changing evolution of it, which has contributed greatly to how fast and at what scale it has been adopted so far.
Under the hood, even at outset, was Copilot powered by what we have kind of all become familiar with as large language model technology, like transformer architecture, this kind of stuff?
Yes. GitHub was working with OpenAI at the time. And so there was like Codex, which was the big first like trained on code specifically model. And that's what was powering Copilot for a while. So now we've reached a point where we constantly evaluate what's the best model to be using for different applications, because we've also moved forward from Copilot, right? The auto completion Copilot, which was the first of its kind, as we're discussing now, right? It was also the first of kind of a set of ideas of where we see AI powered software development going. So you mentioned ChatGPT and the concepts of introducing chats, introducing natural language, introducing conversational interfaces. And that's something that I think ChatGPT showed very clearly has a lot of promise and a lot of application. It doesn't work for all cases equally well, but it does have its place in the whole thing. So now Copilot has evolved, essentially. What used to only be auto completions now has auto completion, but it also has chat, which means that there is the affordance of natural language for developers to ask questions or ask for explanation, and then also Copilot respond in natural language, not just snippets of code. And then we have other evolutions. Like a couple of months ago, we released Next released technical preview of what we call Copilot Workspace. With that one is like completely rethinking the developer workflow and the development environment to make it AI native. So I'm saying all that to say that the idea of Copilot and the product have evolved. And together with that also evolves our criteria of what's the best model to be using. So what we started with is not necessarily what we're doing today, for reasons of performance, of latency, of supporting the different interaction and the different compute that the different interactions mean in the background and so on. So it's a constant exercise on updating what we think is best, and then infusing that into the product.
Let's go to developer productivity, and then I'll bring us back, and hopefully we can talk about how and if Copilot impacts developer productivity. But you alluded to this in your intro. Developer productivity has historically maybe had a little bit of a bad rap. There's the version of this conversation where it's like, I know if I'm being productive and you've got to trust me. And then there's the version of this that is, I'm going to, like the famous story about the Twitter transition where like people printed out all the Twitter code and just counted up how many lines of code ever been contributed. There's like plenty of bad ways to do this. Can you introduce us to what you believe is the good way to measure developer productivity?
So you said a word earlier about developer productivity. You said obsessed, and I think that definitely captures it. I think the tech industry is kind of obsessed, which sometimes seems unfair because I think productivity generally is something that other industries and other sectors are interested in, but we don't actually talk about, like, I don't find myself talking about the productivity of researchers, for example, or of like doctors and lawyers and all of that. But we talk a lot about developer productivity.
Maybe we should talk about the productivity of doctors and lawyers and all of that.
Maybe we should. Maybe we should. But you asked what I think is best. And I think overall, what I think is best is if the metrics and the measurements and the models that we're using to track productivity reflect reality. And one of the problems with how traditionally we've been thinking about developer productivity is it does not match, for the most part, the reality of software engineers, either because it comes from kind of archaic at this point concepts of productivity that comes from like more industrial settings.
Yeah.
But now we're talking about more knowledge work. And so those two don't match. It's also an error of judgment when we always only go for things that we can measure, or even more so things that we can measure easily. It's easy to measure. Like it's very easy to count lines of code or numbers of PRs or all of these things. And they do have their place, right? They show a pace of activity for the developer. But then the conclusions that we draw from that, one, we have to be careful, right? If we see a slower pace, is it the developer that is at fault? Is it the system that they're working with? Is it the process that development is happening in their team or in their organization that is the problem? And most of the times we don't do that diagnosis afterwards. We just say, oh, it's like a slower pace. Why? Like write code faster or write more code. And it is that fallacy. And so most of the times the error of judgment is that we try to oversimplify because they say they want sophisticated measurements, but their attention span only can hold like 2 metrics or 3 metrics. And so you always I see it in my work a lot of the time where people ask for a lot of metrics and a pluralistic view of productivity, but they actually say, but can you please narrow it down to this one metric or like a couple of things that I can put on my dashboard and I can be looking at every day? You asked me what I think is correct. I think the correct thing is to have a view of productivity that matches developers' reality, some of which is perceptual and some of it is observed. So we need to have metrics and ways to measure that capture both of those, right? So there's the part where I feel I'm being productive. That has its place as well, the perceptual version. And then there is the data says that I'm productive in these ways and I'm hampered in these other ways. And so it needs to match the developer's reality, and it needs to be holistic, which means it needs to be operationalized, but way more than just one metric or one dimension. And this is something that I have tried to practice whenever I'm called to do, or I'm interested in doing measurements of productivity. We know, and we definitely live and breathe that at GitHub too, that it's not just a single thing. So when the time came to do the productivity evaluations for Copilot, yes, we looked at the acceleration of developers as one aspect of productivity, but we also looked at satisfaction. We looked at the state of flow. We looked at cognitive load. We looked at like fulfillment with people's jobs, a lot more than just speed.
Yeah, and I was reading some of that. It's very interesting. Maybe I forget the acronym you used. Is it SPACE?
SPACE, yes.
Yeah.
Yep.
Maybe you could talk just a little bit about that framework. And also, like at the end of that paper, you have this big matrix that suggests lots of different metrics. And is the right answer at the end of the day looking at a dashboard that has whatever it is, 18 different metrics or something like that? Or is there a way to take this framework and kind of summarize it into one or two or a few metrics?
The space framework and the metrics that you mentioned are examples of metrics that you could use. The interesting part and the impactful part about the space framework is that it says you need to look at more than one thing. And here are the 5 things that you need to look at. Those 5 things are the dimensions, not the metrics, right? You need to do the extra work on how to operationalize some of these dimensions. So space we mentioned is an acronym. So S stands for satisfaction and well-being. P is performance. A is activity, which is usually when we think about automated measurements, that's where we tend to focus. And then C is communication and collaboration, and E is for efficiency and flow. So there's a lot more there than just activity. And the space framework is a great reminder of look at more than just activity, right? Don't just only count how much of things are happening or how fast. Think about some of these other dimensions. How to operationalize that becomes interesting, right? And some of those dimensions are very much perceptual. So if I'm going to ask about satisfaction, I'm trying to measure satisfaction because we've accepted that it is part of a more holistic way to look at productivity. There's no automatically tracked data that is going to tell me or going to give me a satisfaction score. We need to ask a developer about their satisfaction.
It makes me think a little bit about, we use a product internally called Culture Amp that does like employee engagement surveys, this type of stuff, but it's not focused on one particular type of employee or domain specific questions. It's like, do you feel productive at your job? That kind of thing. Do companies implement kind of programmatic survey-based mechanisms to their software engineers where they're like constantly tracking a series of metrics that get to this type of data?
Yes. So, and we do that at GitHub. I know because I helped with that effort at some point that Microsoft at large also does that. And they do it not only specifically on engineers, but also specifically engineers at different divisions too, because there's nuance, right? That thing that we were saying at the beginning of, it has to match the developer's reality. And the truth is, when you're working on different systems or in different divisions, or you have a different customer audience, your work is affected by that. You may be working with more legacy things or like more modern stacks and so on. And that also comes into some of the speed, the activity, the satisfaction thing. So I do know that a lot of companies, and I'm very glad to see it become more of a trend, that run large scale surveys that are, division, or the design one is separate from the engineering one, is separate from the PM one, where they're trying to gauge productivity from that perceptual angle. And that's just layered on top of things that they get from instrumentation that they have in their systems and things that fit nicely in dashboards. But I see it more and more becoming a trend. And then what are the right questions to include in surveys becomes the next thing to conquer. And so we picked some for our internal surveys, but also for our Copilot investigations, which we now advocate and we suggest and we recommend to our customers. Because eventually they came back and they say, I did adopt Copilot and I have my engineers using it. And now I want to see what the impact is that it has on my engineering teams and my systems. How do I go about doing that? And we give them the same tools, right? And the same instruments that we use to do our own evaluations when we did it for like our whole technical preview and all our user base. And it helps spread the good practice or a more standardized practice. So we don't always feel like we have to reinvent it.
Okay, last thing, and then I want to talk about some of the results of that study. When you talk about developer experience or developer productivity to senior executives, CIOs, CDOs, etc., do they get it? Do they care? Do they consider this a strategic priority? How does this whole conversation sound to somebody who maybe understands technology but is managing a very, very heterogeneous environment with a million different priorities?
It's definitely a very different conversation to have that with, as you say, a CTO, a CIO versus an engineering, like a head of engineering versus a developer. It sounds like we're talking to completely different audiences, and the conversation ends up very different. When I talk with executives about this, there is some reluctance and there is a lot of questions, right? The first wave of questions is always, but what is the developer experience? And I think sometimes it comes with some preconceived notions that developer experience is all about, I don't know, like having perks at work and so on. And
ping pong tables, developer experience.
it is a thing. Like, I think that concept of like the beers on a Friday and the ping pong tables and so on, at the very beginning, that's all people thought developer experience is. Now, fast forward a few years and a few studies, and we realize that there's a lot more to that. So the first wave of questions is always, what is it? And what we talk about is that there are the developer experience is essentially how satisfied or hampered developers feel with the tools and the processes that they use, so that we start developing an understanding of what is it that boosts them, so that we continue to keep that good practice, and what is it that is standing in their way, either because the systems are not efficient and non-performative enough, or there is something to improve in the collaboration between different teams, there are delays in handoffs, all of these things. But to do that, to make that diagnosis, we need to know what the developer experience is in that moment. And it starts with, how satisfied are people with the tools and the processes that they're using today? We have narrowed it down to three main factors. And when I say we, I mean as a research community, because I've collaborated with a few researchers that have been looking at this for a few years. And so through a series of studies, we have narrowed it down to there are three main parts to a good developer experience. One is, it has to do with the flow states. I could be talking about the flow state for hours if someone lets me, but essentially is like you measure that as the satisfaction, which is very perceptual. With the amount of deep work that developers are able to do, the frequency of interruptions, and surprise, surprise, whether they find their work engaging versus boring and repetitive and boilerplate or non-impactful. Then there's feedback loops, which is the time to get, and that's something that you can get from a perceptual angle. You can ask people approximately how much time does it take you, or how slow or fast is a particular feedback loop. But then you also can overlay that with data, because you can see in your systems for at least a few things, kind of end to end, from the beginning of a flow to the end of a flow, how long it takes, and maybe at different stages, or maybe you can split it out to value added work versus not. And so feedback loops for main things that people need to do, how long does it take, or how slow or fast is it to get things approved, to get answers to questions, and that sort of thing. And then there's cognitive load, which is how easy it is for people to intuit and like understand and read code that already exists, or artifacts that they're dealing with. How easy it is to deploy code, not just understand it, but also like be able to work with it, and how intuitive are the tools and the processes that people have to work with daily. So these three pillars, the moment we start talking about those, they start making a lot more sense and become a lot more relatable. And then the next wave, usually, of questions is, why does that matter? Like, why, of all the things that I can use my finite resources for, why should I put it towards this, like improving developer experience? And how do I go about it? And that's why we did a study a few months ago that was specifically focused on measuring the tangible impact of introducing improvements or having these.
And you showed meaningful results. What was it? 50% on some of talk about that a little bit.
Yeah, it's like a 50% productivity boost for when developers have deep work that is dedicated, like it's blocked off, and it's a significant amount of deep work. And this goes back to like, also there's so much piling evidence in terms of the state of flow and the state of deep work for developers, and how it's not only fundamental to them being able to make progress, which is like the more traditional view of productivity, but it's also fundamental of them feeling good about what they're doing, which is the whole like developer happiness is a part of developer productivity, or is an equally important component. So yes, we did find significant results, and I mean that both in the statistical sense and not. We found significant results and really impactful ways that improvements on developer experience affect the bottom line for enterprises. I think that that helps move the conversation a little bit further than before, because now we have evidence, we have data that we can show about what you can expect to get in return.
Join data practitioners and data leaders this October in Las Vegas at Coalesce, the analytics engineering conference hosted by DBT Labs. It's built by data people for data people. Register now at coalesce.getdbt.com. Listeners of the show can use the code podcast20 for a 20% discount. We'll see you at Coalesce.
Let's talk a little bit about Copilot and developer productivity and what you found there. Here's why this is so, I'm sure it's interesting to you for the same reasons, but you have more data here. And so a lot of people throughout the ecosystem turn to GitHub and Microsoft to say, like, is this stuff working? So AI has impacted a lot over the past, whatever it's been, 18 months, 2 years. But one of the things that AI has seemingly the best, whatever, maybe you want to call it product market fit, is around copilots. And that could be a copilot for Microsoft Office. It could, just as well, it could be a copilot for writing code. The workflow fits really nicely because it can suggest things and you can say, that's dumb, I'm not doing it. And when you say that actually is helpful, then there's a level of human oversight there, as opposed to a customer support chatbot, which is like unleashed on the world. And you're like, I hope you're telling the customers good things. So it logically seems to make sense. But many people that need to make decisions about should we use a thing like this or not are not actively in the flow of writing code in this part of their careers, which means it's very challenging for those people to know, does this thing actually work? Does it help? And then you find yourself asking people's impressions, and you get some people who say, like, this is stupid, I'm not using it. I used it for 2 minutes and it just didn't work. And then you have people who say, like, this is life-changing. And it is just very challenging without hard data to know which end of that story, and probably neither is correct. So I'd love for you to position us in terms of what your belief is. How impactful is GitHub Copilot on the day-to-day life of a software engineer today?
Okay, so let's start with putting things in perspective, because as we said multiple times so far, the nuance matters, right? What is Copilot? And let's take like the vanilla version, right? The original GitHub Copilot, the autocomplete. What does it do? It helps developers while they're writing code, and it helps them in a number of ways. So one of the things it does is that it gives them snippets. So it kind of like speeds up the completion of the task. Another way that it helps them is that it prevents them from going to Stack Overflow or their colleague or whatever to get information from them, because the suggestions that they get are not random, they're context aware. And so that means fewer round trips that they need to do. And those fewer round trips mean fewer interruptions, fewer context switches, and that helps developers stay in the flow. Another way it helps them, it makes room, because it takes care of a lot of boilerplate, repetitive style kind of coding. It makes more room for coding and the parts of coding the developers are actually, it's a better use of their time anyway, to be thinking about logic and structure of projects and code bases rather than typey every single line. And so it has all of these different effects that it's not just whether it's like life-changing in terms of the quality of the code that it suggested, but it also has these secondary, let's say, effects, which are very hard to measure because you don't know how many times you would have gone to Stack Overflow and how much time it would have cost you to do that. You do know, however, that you are able to focus more. So like when somebody asks you in a survey or you have a statement to indicate level of agreement, you see that coming through very clearly, that this is something that people experience. That all said, it is a tool that helps in the editor. So it helps developers while they're writing code. And if we go back to what we said earlier, it has to match the reality of how developers work. There's so much more that developers do outside of their editor and outside of authoring code, right? They ideate, they write specs, they think about logic, they do cross-functional work. That all of these areas where Copilot doesn't come into play at all, or if it does, it's to a much lesser degree. I think there have been studies from Microsoft. We've also done our own evaluations, and it turns out developers code a fraction, and not even a big fraction, of their daily work. Only a small fraction is coding. So that means the Copilot effect is also going to, within that 2 hours or 3 hours a day, the developers are actively writing code, they're likely to see an impact. But then it's not a magic bullet, which I think sometimes I have heard at least executives kind of expect, right? They're expecting that they're going to adopt this tool and it's going to change everything. It's going to change some things when developers are writing code, and now they can do that more efficiently. And in like a lot of cases, it's more joyful of an experience for them. But if an organization has inefficient systems that cause a lot of delays, Copilot is not going to change that. In fact, some of those delays are probably like watering down some of Copilot's effects in terms of speeding up things.
You're very effectively managing our experiences downwards.
So it has to be put in perspective, I guess is what I'm trying to say, right? It's what even is the organization trying to achieve with adopting Copilot? Because sometimes they're adopting it because why not, or because it's the new shiny thing. And not that that's always bad, but it works way better when you have a purpose for which you thought this is the right fit of a tool. And then you bringing in with some objective in mind.
I guess maybe the thing that, if I can try to put myself in your shoes for a minute, probably the last thing that you want is to have an executive at a large company who is obsessed with the idea of AI, and they're just like, GitHub Copilot is going to make us produce 10x more code, and then a year later, they're like, why didn't we produce 10x more code? And that's probably like the wrong expectation to come in with.
Yeah, because there's a role to play for the company as well. So we have seen examples of Copilot being adopted very successfully in companies when some things are in place. Like there's a purpose and a goal behind adopting it. There is a sense of what areas we're expecting it to affect or help. And therefore, in 6 months or in 3 months or in a year, when we're going to do an evaluation, we have a set of metrics and measurements and sources of information that we're going to leverage for that. And also when the ground has been set. And that means there are people who are championing it, and there are people who are going to train others to use it. That we, like, hands down, that wins every time, where there was a first wave of developers that have used Copilot that kind of advocated for it to be introduced. And that first wave acts as not only champions, but also as like a source of education and training for their colleagues who are now going to be adopting this tool. And so there are all these other things that are going to play into how successful Copilot and Copilot's adoption is going to be in an organization. And we have like a learning path that we put together in some ways to kind of guide customers through it. And I think it's public, so we can definitely share that with you to give some guidance, because I guess the takeaway here is if you're just planting the tool and hoping for the best, that's going to make it way harder to see the fruits of that adoption.
So you did a controlled experiment. You published the results of that. Can you share some of them here? Because my read of this is that the control group that did not get Copilot to complete the task performed less well. Is that fair to say?
It was not as fast. Yes, it was way slower. That's what I'll say.
Okay.
So yes, the controlled experiment was focusing specifically. So after we had a large scale survey, we got all these benefits that we realized Copilot is having in addition to speed. And so the flow and the fulfillment and the satisfaction that I mentioned earlier, the developer happiness part. One thing that came through very clearly was that I think we had 96% agreement on the statement that people complete especially repetitive tasks faster when they're using Copilot. That doesn't tell us anything about how much of an effect it has, right? It only says almost everyone agrees that it has this effect. And so we did the controlled experiment because now that we have this very strong signal that people are experiencing faster completion time, we probably want to measure how much of a difference it makes. So we had 2 groups. We had 95 professional developers. We split them randomly into 2 groups. They had exactly the same conditions. We gave them the same task to complete, which was to write a HTTP server in JavaScript. And then the only difference between the two, and that's where the controlled part comes in, the only difference between the 2 groups is that one group used Copilot to complete the task and the other one did not. And so then we compared 2 things between the 2 groups. One was their success rate. So what's the percentage of each group that completed the task at all? And then we also looked at the completion time, meaning from the first commit that was automatically generated, so that we have like a global one starting point for everyone. And then to the final commit that passed the test suite that we had attached to the task. What was the time and completion time? And the result was that the group that used Copilot was completing the task 55% faster. And that's, again, significant both in the statistical sense and just like the difference is too big to ignore. And that started like a wave of us understanding the level of benefit that this can bring. That does not mean 55% all the time everywhere, because we just talked about the nuances of things, right? But it was a first indication of this is the level of effect in terms of speed that Copilot has.
I am curious about a million things about this result. Maybe the first big thing that stands out, maybe we could translate this into my world for a second. So the world of analytics engineering is this hybrid world where analytics engineers are building data pipelines and conducting analytics, but they're doing it from a background of software engineering best practices. Typically, there's a blog post in our space by someone named Nick Schrock. I love this blog post. Came out very recently. Talked about medium code. He outlines this framework of no code, low code, medium code, and high code. And so low code would be, more drag and drop-y type experiences, maybe some configuration done in there as well. High code would be kind of what you would think about in a C++ or JavaScript or Python or whatever. You can do whatever you want. And then there's this world of medium code where you're kind of more constrained by the framework. You're given like very specific boxes to work in, but within those boxes, you're really writing code. And maybe this is a Jupyter notebook or this kind of stuff. It seems to me that maybe one of the things that might be true of a Copilot type experience is that if you're in kind of a well-defined environment, you're working in a clear framework or something like that, that it might help more. Whereas if you have a million lines of COBOL from a legacy system that's been around for 40 years, like that's going to be pretty freaking hard for it to reason about effectively.
No, I completely agree. And we've definitely seen different performance in terms of like one of the metrics that we look at is the acceptance rate of Copilot suggestions.
Interesting.
And we've definitely seen that's not the same across languages. It definitely performs from that perspective, like how much of a good fit the suggestion was to lead to a developer accepting it is different for different languages, for example.
Do you have anything you can share in terms of like languages in which are better and worse?
I believe that I will have to check and we can definitely share resources with you, but I believe that it's the best performance it has is Python, in Python code. And so, which I think goes back to some of what you were saying is like, if there is it's also part of the training, right? It probably has seen a lot more of some types of code and less so of others. So there's a lot more going into it. But I will also say that we have found both, again, from the perceptual and from the measured evaluations, that it also performs better with what we call boilerplate or repetitive tasks. Again, because I think it has been trained with more examples of those rather than some more abstract, more specific to a particular use case kind of task where it's harder to replicate. So it's harder to get more targeted suggestions. And so if I'm looking at what you said more broadly, like when there is a better defined box, within that box, it is going to do better. And we see that both in terms of acceptance rate, but also the repetitive boilerplate stuff.
Better defined box and also more examples of how to do the thing inside the box.
Yes. Yeah.
How about greenfield versus brownfield projects? Like, the assessment that you did in this research you were talking about seemed to me to be a very greenfield project, like write a web server from scratch. If I go to a Fortune 500 company that's got a old system that's used to process insurance claims or something, like, can I drop in Copilot to developers in that environment and have it boost their productivity?
Again, Copilot has evolved, so it's much more context aware now. It looks at neighboring tabs. It can look at your whole code base. We have like fine tuning that happens. So yes, now, right? That was not necessarily the thing at the beginning. But now with the evolution of the tool and the product and its inner workings, yes, it can do a lot more, and it can do a lot more that is specific to the code base, specific to the language, specific to the context.
It will learn the code base of the project that it's working in.
Mm-hmm. And this is something that we're also keeping in mind as we're thinking about future versions of Copilot. So I mentioned earlier that we have a technical preview going right now. It started a couple months ago of Copilot Workspace, where we kind of reimagine the whole flow that a developer goes through from when they write an issue or a task all the way to writing the code that is the pull request that kind of implements the original idea, with AI helping in different ways along the way. And we can get into that if you want. But that's one of the main concepts there, is that Copilot Workspace, to be able to help, it will need to first make sure that it understands the task, that it understands the code base, right? And anything else that you care to give it as information. And so the first part of that flow, after someone has written an issue and they say, okay, let's start our task with Copilot Workspace, is that it creates a spec where it says, here's what I understand about the code base, the state of the code base, and the task that you're asking to do. And then from that, here's a plan of all the changes that will need to happen in these specific files, and here are the diffs for them, and so on, so that it not only understands, but it also shows you that it understands.
Okay, that's cool. My last question to you was going to be about agents, and this is starting to feel a little agentic. It
yes,
can create a plan and then execute multiple stages of that plan and explain to you what it's doing along the way. That's cool. Does that mean that gosh, I mean, I feel like everybody in the software ecosystem maybe started their career at some point triaging issues. If you triage issues, the main thing that you tell people over and over again is like, you've got to specify the issue more clearly. But if this works the way that you're talking about, if there is a well-specified issue, is the hope that that is actually sufficient to take a first draft at actually writing code to resolve the issue?
Yeah. I mean, there were a couple of keywords there that I think make all the difference. One is like a well-specified issue. And like, I don't even know that we know what that is.
Sure.
And I think it takes trial and error between the developer and the AI, therefore between like the issue and the spec, to actually arrive to the point where we think that the issue we now know was articulated clearly enough. Then there's ambiguity in natural language, right? What if the two of us are talking about an issue and I explain something, you can like fill in the blanks probably way better than how much I need to articulate it for an agent or for like any AI tool to get what I'm saying and actually like put it into the work appropriately. So I think that it could arrive there. But the way that we're thinking about it is we're thinking about it more as a like partnership between a developer and an AI tool or an AI agent.
You imagine there's iteration on this process too.
There is constant refinement because at this stage, that the stage that we're at, with models working the way they do and with ambiguity in natural language playing the role that it does, perhaps in the future, the ambiguity is dealt with differently and models function differently and have different capabilities, and that becomes lesser of a concern. But today, we find that this needs the iteration and the refinement is absolutely necessary. And it helps the developer kind of narrow down and think through what they're asking for anyway. So it has that benefit as well, but it also helps get better output from the tool.
Yeah, your rubber duck actually becomes
yes
your AI model. This has been fun. I feel like we could talk about all of this for a lot longer, but I feel like this has been a good overview. We ask the same question to everyone who is on the podcast. What do you hope is true for the software, data, AI ecosystem in 5 years? And this is not a, what are you worried? This, what do you hope will be true?
Yeah. So you're not asking for a prediction. You're
Correct.
asking for an ambition, right? A
Yes.
vision. Yeah. There are a few things. So I'm hoping that models are going to become more reliable and accurate. And they were going to be able to deal with the ambiguity in language that we were just talking about, because I see that as the vehicle in us, or developers. Let's focus on developers for now, or honestly, data analysts becoming more systems thinkers. So that they go up a level of abstraction, because some of the more mechanical parts of development or analytics can be in a trusted way handled by AI in this form of partnership. And so then the developer becomes more of a system thinker, which means that they are thinking more about how systems and applications should behave and how to orchestrate, and they're monitoring what the AI tool or agent is producing and so on. And they absolutely intervene if and when they want to, but otherwise they're focused more on the higher level rather than the lower level details of the work that they're doing. I think that that's something like this kind of system thinking has always been a great quality for software engineers, but you usually see it in more experienced software engineers. And I think that if this shift happens and the most mechanical parts become more AI powered or more AI informed, I can see how the system thinking is something that developers can exercise as a muscle earlier on in their career, and it could accelerate their growth. And the other thing that I'm hopeful for, which I think we've started seeing, is have kind of more personalized, more tailored experiences. So one thing that I've been thinking about a lot is learning programming, because I've interviewed developers about their learning and how they keep up to date with things and so on for like a number of times. And one thing that comes up again and again is that the traditional tutorial or the traditional textbook or assignments or videos even that people look at, it's all created for the universal learner, and us individuals are not the universal learner, right? There's always a delta between how I learn, my pace, my preferred way of like learning things, the need that I have to learn something. I don't have to look at the whole video. I don't have to read through the whole tutorial. So having a personalized learning experience where it is like the tutorials can be AI generated and they can be bespoke to me and what I need and my level of experience and my familiarity and my pace. To me, that seems very, very promising and something that I can see that becoming a more engaging and more valuable experience. And I can see how that sort of thing kind of transcends disciplines as well. So it's something that I think we can all benefit from. I'm very hopeful about that.
Wonderful. I love it. Eirini, thank you so much for joining us today. This has been a great conversation.
Thank you for having me. This was great. Thank you.
The Analytics Engineering Podcast is sponsored by DBT Labs. I'm your host, Tristan Handy. Email us at podcast@dbtlabs.com with comments and guest suggestions. Our producers are Jeff Fox and Dan Poppy. If you enjoyed the show, drop us a review or share with a friend. Thanks for listening.